Okay, so let's have a look at, we'll continue looking at this idea of motion, right? I emphasized that we were looking at motion in a straight line, and generally we look at particles, and they'll give you a lot of information here. But the important thing to remember in this topic is to think about what you already know about the nature of motion and their derivatives, right? We've looked at three different kinds of aspects of motion, right? We looked at displacement, velocity, and acceleration. And to get from one to another, what did I figure out I had to do? To get from one function to another.
Derivative or integration.
That's exactly right. We mainly focus on looking at the derivatives, right? If I have a displacement function, I'll take the derivative to get to velocity, take the derivative to acceleration. And the reason why we can do that is because I'm looking at rate of change here, right? Now naturally it follows that if I take the derivatives to go down those layers, then yeah, to go backwards, I would just look at integration, right? It's kind of like, do you remember in Inception when they go down those layers of the dreams and stuff?
Hey, don't ruin that movie. I've not seen
The
it.
spoilers? Okay. Well, basically it's the same idea, right?
As if you haven't seen Inception.
Hey,
Yeah,
don't ruin
you
it.
haven't seen it.
You just ruined it for me, sir.
Okay.
Okay.
Oh, no more spoilers after that. But basically,
I'm not
imagine just like having different layers, and we're going down those layers. Sometimes we're not given that top layer. Maybe we're given the acceleration or the velocity, and they want us to come all the way back up to displacement. That's what we're going to look at today. Now remember, for displacement, I mark that as x. And if I'm thinking about that in terms of an integral, what do I need to integrate to get my displacement function?
Velocity.
Yeah, I'm just going to be integrating v. Now it's important to note here, right? We use x in motion, we use x as the subject, because that's talking about displacement. What am I going to be integrating with respect to?
B.
So v is the velocity function, and I'm not integrating with respect to x traditionally,
T.
because
Oh,
that's
my
what
God.
function. And what do you say, Mitch?
Time.
Right, because think about it. Motion is talking about where you are at a certain time. So, when I'm looking at integrating with respect to something, then I'm thinking about integrating with respect to t, and I write that as dt. Same idea here. If I'm looking for the velocity, I'm going to have to integrate the acceleration function, right? And again, same idea with respect to dt. Now, when I first talked about integration, right, we talked about having indefinite integrals, and so at the end, you always need to say plus c, because there can be a constant there. And it kind of felt like there was not much point to it. I'm just tacking on a plus c at the end, and it's just like, by convention, it looks nice, right? But when we look at motion, it is very important that you have those constants there, because these questions will actually ask you to find them. Now, I'll give you an example here.